Welcome friends to my YouTube channel. Now in today's lecture I shall discuss an important topic that is at first we have discussed the cohesion pressure. Okay, so cohesive force, cohesive force and cohesion pressure, cohesion pressure. Now, at first, let us try to understand what happens for a plane surface. Okay, if the surface is a plane, then what happens? Now, we all know that for a plane surface, the resultant force due to surface tension is zero, since there is equal and opposite amount of attraction from both sides. Okay, this attraction and equal attraction from both sides. So for a plane surface, the resultant force due to surface tension is zero. Okay, so for a plane surface, resultant force due to surface tension is zero. Now as force is zero, pressure is zero, because pressure is from this side is exactly equal to the pressure applied on other side. So these two cancels. Okay, so pressure from this side must be equal to pressure from this side. Okay, so if this is say P1 and this is P2, so obviously this. Okay, so this is for a plane surface. Now let us try to understand the case where the surface is a concave one. Okay, what happens if the surface is a say concave one? Okay, say okay, we draw two tangent, one is this and another is this. Okay, and if we resolved it into two components, say this is this and this is this, and for this is this and this is this. Okay, at first we draw a tangent and then we resolve this into two components. Okay, so this is the horizontal component, this is the vertical component, and for this is the vertical component, this is the horizontal component. We see that horizontal components cancels each other, there only remains the vertical component. Okay, so we see that for a concave surface, the resultant force due to surface tension acting in upward direction. Okay, upward direction. So for a concave surface, the resultant force due to surface tension acts outward direction. Okay, so that means what happens if this is a concave surface. Okay, okay, if this is P1 and this is P2, since the force is effective in outward direction, that is concave side, the force is large. So in this case, the pressure in the concave side is always large. So that means cohesion pressure is this. The pressure in the concave side is always large than the convex side. Okay, fine. Now if we take the surface as a convex surface, then what happens? If we take the surface as a convex surface, then just look this. Okay, 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 so this is the horizontal component and this is the vertical component, and for this is the horizontal component, this is the vertical component. So horizontal component cancels each other and only remains the vertical component. So for a convex surface we see that the resultant force due to surface tension acts along the inward direction. Okay, so for a convex surface, the resultant force acts along inward direction. Okay, so if this is a convex surface, okay, so in this side the force is effective. Okay, so if this is P1 and if this is say P2, then what happens in this case? Pressure in this side is greater than this, that means this. So we see, and this side is concave. Okay, so previously we see that the pressure in the concave side is larger, and in this picture if you see that also the pressure in the concave side is larger. So we can conclude that for a excess pressure always lies in the concave side. Okay, excess pressure always lie in the concave side. I explain these things in order to show that why the excess pressure lies in the concave side. Okay, so the excess pressure always lie in concave side. Remember this thing. Okay, concave side. Okay, fine. Now let us take a suitable example, that is, let us take a suitable example, say spherical soap bubble. Spherical soap bubble. What happens? It has a convex surface. A spherical soap bubble has a convex surface. Okay, how? And if we draw this picture in another way, then it looks like this. If we draw this picture in half portion, that it looks like this. Okay, so just we draw the half portion. So what happens? Previously we see that for a convex surface, what happened? The resultant force acts in downward direction. Okay, resultant force due to surface tension always acts in downward direction. Okay, so spherical soap bubble or spherical soap bubble has convex surface. So obviously the force due to surface tension acts in the downward direction. Okay, so what should be the force due to surface tension? What should be the force due to surface tension? So force due to surface tension, that is surface tension multiplied by length. Length means the circumferential length. Length means circumferential length. This total portion we have to take. So if r is the radius of the sphere, so this is the total force due to surface tension. Okay, and since a spherical soap bubble has two surfaces, we can again multiply this by 2. So 4 pi rs. Okay, For a spherical soap bubble, there are two surfaces, so we multiply by 2. Okay, 4 by Rs. Now another force acts on the system. What is that? Now we know that the excess pressure is always lie in the concave side. That means this side, concave side, this side. So due to excess pressure, the liquid will tend to spread. So there is a excess pressure in the concave side. So due to this pressure, a force acts in the opposite direction. Okay, the liquid will try to stretch due to the inner excess pressure. So due to excess pressure, the force is what? Excess pressure P, say, multiplied by area. So what is the area? Pi r square. So we have to find out the excess pressure. So in equilibrium, the two forces are equal. So this is the force due to excess pressure in the concave side, and this is the force due to surface tension. So pi cancels, this is r, so P is what? 4s by r. So this is the excess pressure in case of a spherical soap bubble. Just I take the example of it. Okay, now in today's lecture I shall explain the cohesive forces and cohesion pressure with a suitable example. So dear guys, please like and subscribe my videos to get latest videos, to get latest updates. Okay, so in my next class I shall going to discuss another issue, that is the excess pressure inside a curved surface. Okay, so today is up to this. Thank you.